Hello. I'm going to tell you about a rather remarkable planetary system, the Trappist-1 system, which consists of 7 planets in a very compact solar system. The star Trappist-1 itself, not to scale, is a very small star compared to the Sun, and is very dim compared to the Sun. We have 7 planets labeled B through H. Trappist-1a is considered to be the star itself. That actually would fit. If I just move over a bit, that whole system would fit well inside the orbit of Mercury if you placed it in the solar system. Now, there is another remarkable feature of this system that it, in a real sense, embodies the music of the spheres as Pythagoras considered it, in a way that our own solar system does not. But just to talk about some basic orbital mechanics, when a planet is farther from its star, it takes longer to go around. Its year is longer. And that's just because of Newton's laws of gravitation. But if you think of each cycle of the orbit going around as being like the vibration of a string, you can consider the outermost planet to have a rather low pitch. And as you go further in, the planets have a higher pitch. Now, that would be true for any system, but they don't necessarily make a nice harmony. The solar system doesn't. Our planets don't, not remotely. But the Trappist system is in what's called a resonant chain, in which the periods of each successive orbit are in the ratio of small integers. And not only are they in the ratio of just any small integers, the equivalent orbital pitches correspond to the intervals, the ratios that make up the Pythagorean theory of harmony, which is the basis for the most pure musical scale that many musicians still use today. So I've tuned up my magical disappearing guitar to represent the pitches of all seven planets. That took a little bit of doing because of there's a big range of pitches there. But we start with the outermost planet, Trappist-1H, has the lowest pitch, and the next planet up is a ratio of 3 to 2 in pitch relative to the outermost planet, and that is a perfect Pythagorean fifth. It's like a C and a G on a piano, and they make a nice harmony together. It's the fifth that goes into a major chord, and the next pair of planets from G to F, that goes up by a perfect Pythagorean fourth, and when you follow a fifth by a fourth, you get an octave, and so there's your octave, and the three sound rather nice together. And now the next one is up by a fifth again relative to F. So 1E is up by a fifth, perfect Pythagorean fifth relative to F's. So you get the same interval there as we had here. Now, actually, an interesting thing is that the first 3 notes in the system are the opening notes to Also sprach Zarathustra, which is the opening theme of the movie 2001: A Space Odyssey. Richard Strauss could not have known that, but it's interesting how that works out. But if you put all the outer 4 planets together, it sounds rather nice. Now, the next to get the next planet, I have to go up onto a fret, and the next planet continues walking up the circle of fifths. Basically, it's a perfect fifth. It's another perfect Pythagorean fifth up from the previous planet, and so this interval again is the same as this interval, and the same as this interval, and they sound rather nice together. Then the next planet is the one that's the odd one out. It's in the ratio of small integers. The pitch is 5/3 up from the from the previous one. D is 5/3 up in pitch from, C is 5/3 up in pitch from Trappist 1D. But that's not part of the Pythagorean scale. The Pythagorean scale is based on powers of 2 over powers of 3. It doesn't have a 5 in it. But this is 5/3. But the interval actually sounds pretty good. It's a kind of a super Pythagorean interval, you might call it. And it's not actually a bad sound. And it sounds a little bit un-Western, but not at all discordant. That's a rather nice new note to have in your scale. Finally, the last planet is way up here. The innermost planet is way up there, and although it also is in a non. Let's see if I can actually get that one. I have to treat the guitar like a dobro, so I can, because my hand span is not enough. But I can give you the. I think I can get you. So that's also one of those super Pythagorean intervals. But if I skip C. I get my interval going in between B and D. The interval is a Pythagorean pure fourth up in the next octave, so it sounds rather nice. And that is the music of the spheres as embodied in the Trappist 1 system.